Good morning, boys and girls. This is day 1 of your week 7 distance learning packet. There should be a snowflake in the top right corner with the number 11 on it. Remember, this video is a tool to help you on any questions where you get stuck. It is also a tool to help you check your work and correct your page. Number 1, find the sum. 9 plus 3 equals 12. I'm going to write down the 2, bundle the 10 ones, and move them to the tens place. 1 plus 3 equals 4. 4 plus 8 equals 12. Write down my 2, bundle the 10 tens, and move them to the hundreds place. 1 plus 6 is 7. 7 plus 6 equals 13. Write your 3, bundle the 10 hundreds, move them to the thousands place. 1 plus 7 equals 8. 8 plus 4 equals 12. Remember to count your digits to place the comma. 1, 2, 3. There's my comma. You know you're right if all your commas line up, because they should all line up with each other if your place values are lined up. 7,639 plus 4,683 equals 12,322. Number 2, find the difference. Remember, difference means the answer in subtraction. 3 subtract 6. I cannot do that. If I have 3, I can't take 6 away. So you need to go to the place value to the left. However, I see that my place value to the left is a 0. So I'm going to go to the left again. I see that it's another 0. So I'm going to go to the left again. I'm all the way over here in my thousands place. I'm going to take one of my thousands, so the 9 becomes an 8. And I'm going to unbundle the 1,000 to make 10 hundreds. But I need to get it all the way back here to the ones place. So I'm going to take one of those hundreds, so I only have 9 left. I'm going to unbundle it into 10 tens. Then again, I need it over here in my ones place. I'm going to take one of my tens, that leaves me 9 tens. I'm going to unbundle it so I have 10 ones. I already have 3 ones. 10 plus 3 equals 13, so I have 13 ones. Now I can subtract. 13 subtract 6 equals 7. 9 subtract 4 equals 5. 9 subtract 3 equals 6. 8 subtract 4 equals 4. Now remember, if you have commas, you can simply bring your comma down, but double check and make sure you have 3 digits behind it. 1, 2, 3. 9,003 subtract 4,346 equals 4,657. Number 3, find the product. I'm going to go to my scratch paper for this one. Remember, product means your answer and multiplication. I'm going to use an area model. I have 2 digits times 2 digits. In order to use my area model, I need to take these numbers and put them into expanded form. That means I'm stretching them out to their place values. 81, this 8, the value of that 8 equals 80. The value of this 1 is 1, 1, or 1. Then I come over here to 62. The value of this 6 is 6 tens, or 60. The value of this 2 is 2 ones, or 2. Then I can multiply. Remember that this is called the area model because it's length times width. So inside this rectangle, I'm going to multiply the length 60 times the width 80. I know with place value, when I'm multiplying multiples of 10, I can just look at the zeros. 0, 0, count them up and put them in my answer. And then I can multiply this basic fact, 6 times 8. If you don't have your basic facts memorized, you can go to a multiplication table, find the 6, and where the 6 and the 8 meet, that's your basic fact. That's the product. 6 times 8 equals 48. Now, 6 times 8 equals 48, but 60 times 80 equals 4,800. 60 times 80 equals 4,800. Then I'm over here in this next rectangle. Again, it's the length 60 times the width, which is 1. Anytime we multiply anything by 1, it's the number itself. So 60 times 1 would simply be 60. Then I'm down here in the bottom left rectangle. I have 2, the length, times the width, 80. I know because of place value, when I multiply a multiple of 10, I can count the 0 and put it in my answer. Then I'm left with the basic fact 2 times 8. If you don't have those memorized, go to your multiplication table, 2 and 8, and where they meet in the middle, here's my 8. That's your answer, 16. Remember though, I'm not doing 2 times 8, it's 2 times 80, so that equals 160. Then I'm in my last rectangle, I have 2 times 1. Again, whenever you multiply by 1, it's the number itself, so 2 times 1 equals 2. Now these are all partial answers. I now need to add them up. 0 plus 0 plus 0 plus 2 equals 2. 0 plus 6 plus 6 equals 12. I'm going to write the 2, bundle the 10s over the hundreds. 1 plus 8 plus 1 equals 10. So I'm going to put a placeholder, bundle that 10 and move it to the thousands. 1 plus 4 equals 5. Count your digits, 1, 2, 3. Put your comma, 5,022. 81 times 62 equals 5,022. We are going to skip number 4, find the quotient, because it is working with a 2-digit divisor. We don't need to learn that in 4th grade. You can learn it in 5th grade. Then we're going to go to question 5. Is the second number a multiple of the first number? Go over to your multiplication chart. Remember, multiple sounds like multiplication because your multiplication chart is full of all the multiples. So if I want to know if the second number, 80, is a multiple of the first number, 9, I'm going to find the first number on my multiplication chart, and then I'm going to follow it over and see if 80 is on there. So we start with 9 times 1. 9, 18, 27, 36, 45, 54, 63, 72, 81. 81 is too big, so we've passed it. And the number before was 72. So 80 is not in the row for 9s. Therefore, no, it's not a multiple. So you can simply write no. Number 6, use place value to multiply. So they're just talking about the trick when you know you're multiplying multiples of 10. I have a 0 here and a 0 here. You can count up your zeros. So 1, 2 zeros. And then you just multiply the front numbers. 4 times 1. Everybody should know 4 times 1 equals 4, because anytime you multiply a number by itself, it equals itself. Number 7, draw a triangle and partition it into 4 equal parts. Remember that partition simply means put it in parts, and how many parts do they want? 4. But there's a key word, they have to be equal. So this is a tricky one. So first I thought, okay, I'm going to draw a triangle, and it looked like this. And I'm going to go ahead and draw some lines. Okay, there's one, and I need 4 parts. I need 4 parts. So I did that. But if I look at it, those parts are not all equal, so it can't be that. Okay, well then I thought maybe if they all come down from the vertice. So then I thought, okay, I'll do one there, and then I'll do another one coming out from the same point, and I'll put it kind of like in the middle here, and then I'll do another one again from the same point, and I'll move it to the middle here. But those are not equal parts either. Their angles are different, so they're not equal. So that didn't work. So then I thought, how else could I do this? Then I thought, well, maybe if I go to the center and I put them all like that, maybe I could do it that way, putting it to the center. Okay, so let's try that. So I had one there, then I put one kind of in the center here, then I put one here. And I could already tell this isn't going to work because this is like a smaller triangle, and then this is a quadrilateral. That's not going to work. Then I thought, maybe if I use a different kind of triangle. So I put a line here, and I kind of tried to do the same thing, and I thought, okay, that's not going to work because, again, this is a quadrilateral, this is a triangle. That can't work. Maybe if I turn it and I start making it like this. But I could tell that my pieces, they weren't going to be the same size, and I was having the same problem. This is a triangle, these are quadrilaterals. Even if I add another line, those are not equal parts. What can I do? Well, finally, I got a little help, and I figured out that if you want to make it an equal part, you have to draw a triangle here in the center. And now I have 4 equal triangles. 1, 2, 3, 4. Can you see that? Get it a little better. That was a pretty challenging one, and I had to go and get help for that one. And that's okay. That's okay if something's challenging and you've tried and tried and tried and you can't seem to figure it out. It's okay to go ask for help. And then the next time you'll know how to do it. Okay, question 8 is a word problem. And we're going to use our cubed strategy, but before we do, we're going to go ahead and just read our question. Ivy melted a pile of snow and got 6 gallons of water. Ruby melted a pile of snow and got 9 quarts of water. How many quarts of water were there combined? I'm going to go back through, and this time I'm going to use the cubed strategy. I'm going to circle my numbers in units. Well, I saw 6 gallons. And I saw 9 quarts. Then it says underline the question. How many quarts of water were there combined? Box the keywords. It wants to know how many combined. Well, that's another word for saying in all. How many in all? So I'm going to put these 2 measurements together. Evaluate. So what are the steps that I have to do? Well, I know that because it says combined in all, I'm going to have to add. But I also know I cannot add gallons and quarts. I have to change them into the same unit. And I forgot to box this keyword where it tells me that I have to put it all into quarts. So I'm going to need to convert the gallons into quarts before I add them together. And then the last one is draw a picture. So I'm going to go down to my scratch paper and I'm going to draw a picture. Okay, so this was the picture I drew. I remember that when we were doing our measurement unit, we learned this picture when we were talking about gallon land. And we drew the letter G, and inside there were 4 Q's, and that stood for gallons and quarts. And this picture was a picture that would help me to remember that there were 4 quarts in every gallon. So I also did an input chart, and it tells me 1 gallon equals 4 quarts. If Ivy melted a pile of snow and got 6 gallons of water, but I need to know how many of quarts, then I'm going to say, okay, 1 gallon. Then you could say 2, 3, 4, 5, 6. But I know that this each one is saying 1 times 4. 1 times 4 equals 4. 2 times 4 equals 8, so there would be 8 quarts and 2 gallons. 3 times 4 would equal 12. There would be 12 quarts and 3 gallons. Well, I can just go to my multiplication chart then and find out what 6 times 4 would be. Because 6 times 4 is going to tell me how many quarts Ivy had. So I'm going to go to my multiplication chart, and I'm going to find 6 times 4. So here's 6, and I go up and I find the 4, and where they meet, 24, that's my answer. So 6 times 4 equals 24. In 6 gallons, there will be 24 quarts. Okay, so then I might draw a little tape diagram that helps me to see that Ivy then has 24 quarts of water. This is Ivy, so I'm going to write Ivy above it. And then it says Ruby has 9 quarts of water. And I know 9 is much smaller than 24. So my tape diagram will be smaller, and this has 9. And since my question says how many quarts of water were there combined, I then have to find how much both tape diagrams are. I'm going to go ahead and add then to find out 24 plus 9. 4 plus 9 equals 13. Write your 3, bundle the 10 ones over to the 10s. 1 plus 2 equals 3. So all together, how many quarts did they have? They had 33. And remember, you have to put your units, and then you also have to put it in a sentence to show that you understand what the number represents. So over here, there were blank quarts of water combined. I'm going to write 33. Okay, let's go to question 9. Question 9. Reduce the fraction to simplest form. I showed you a very easy way to use your multiplication chart to reduce fractions into their simplest forms. Simplest form means they want your numerator to be the smallest number you can get and your denominator to be the smallest number you can get. So you're going to go to your multiplication chart. Now, when I go to my multiplication chart, I'm going to find 6/8. However, I don't want to do this right here because this isn't going to tell me any equivalent fractions that are smaller. So I want to find it somewhere out in the middle of my multiplication chart. So here I see 6, but I don't have 8. So here I see 6. Oh, and I have 8 right there. 6/8. Do you see your fraction right there? To find an equivalent fraction, you have to keep the numerator in the same row and the denominator must also be in the same row. And since it wants simplest form, I'm going this way to the smaller numbers. Okay, so 6/8, then an equivalent fraction to 6/8 equals 3/4. And if I look, I can't find 3/4 anywhere else on my multiplication chart, so that must be as small as I can get it. 6/8, the smaller equivalent fraction. When I say smaller, I just mean smaller numbers. Remember, the fraction, if I were to look at a picture of it shaded, would be the same amount, 3/4. Now I know that this most likely is in simplest form because I know that 3 is a prime number. That means it cannot, the only way to get 3 is saying 1 times 3. It has no other factors. That's how I know this is in simplest form. The only other number that this could be is a 1, and that would only be if there was a number that could go into both 3 and 4, and there is not. So 3/4 is your simplest form.
Put 16 ounces on a scale. It'll weigh 1 pound without fail. Pick up 16 ounces off the ground, and you just lifted 1 pound. And if a ball weighs 16 ounces, a pound hits the ground every time it bounces. Bounces, bounces, bounces. If you weighed 2,000 pounds, you couldn't run, cause if you weighed that much, you would be 1 ton. But if you found treasure, it would be real fun. If all that gold weighed up to 1 ton, cause all of that would make mounds and mounds, as a ton is equal to 2,000 pounds. 2,000 pounds. 2,000 pounds. I looked up how many ounces were in a pound, and 16 ounces is what I found. Then I stacked up pounds till they weighed a ton, and it took 2,000 until I was done. Lots of things weigh about an ounce,
like 4 quarters,
or a friendly mouse.
Lots of things weigh about a pound, like this bottle of soda
that my teacher found.
Lots of things weigh about a ton, like a small car
driven by a really hip nun.
I looked up how many ounces were in a pound, and 16 ounces is what I found. Then I stacked up pounds till they weighed a ton, and it took 2,000 until I was done.
Okay, so question 10 says use greater than, less than, or equal to compare the measurements. You're comparing 3 pounds with 32 ounces. So if you remember from our measurements unit, we learned that in 1 pound there were 16 ounces. And since you have, so if we want 3 pounds, if this is 1 times 16 equals 16, then you would say 2 times 16, then you would say 3 times 16. So I can go ahead and make a small little area model. Here's my scratch paper. 3 times 10 equals 30. And then over here it's going to be 3 times 6, which equals 18. Then you're simply going to add the two numbers together, 30 plus 18. 0 plus 8 equals 8. 3 plus 1 equals 4. So 48. 3 times 16 equals 48. So if 3 pounds is really 48 ounces, which is greater, 48 ounces or 32 ounces? I can see that 48 is greater, so I'm going to put 2 dots there, 1 dot next to 32, and then I'm going to connect my dots, and that gives me the correct sign. 3 pounds is greater than 32 ounces. Okay, boys and girls, that's it for today, and I will see you tomorrow. Bye.